Use the algorithm you developed for exercise 87 to convert the integers in 88 through 90 to hexadecimal notation. So we need to convert 693 to hexadecimal notation by altering algorithm 5.1.1 so that we can do repeated division by 16. Now the only edit we need to make is we need to change these two numbers here for the mod and the div from 2 to 16 so that we divide by 16 repeatedly instead of dividing by 2. So now let's make a trace table. We have the variable q, we have the variable I, and we have a list for our remainders. So our input A is 693, which means q is going to be defined by 693 and I is going to be 0. After that, we start this while loop. Here both I equals 0 and q does not equal 0, so the conditions of this while loop are definitely met. First, we define r at the index I equals 0, which is the first element here, is going to be q mod 16. So we need to do 693 divided by 16 using long division. So how many 16s go into 693? We're going to need both the quotient and the remainder for this. 16 goes into 69 4 times, and 16 goes into 53 3 times. And that leaves us a remainder of 5. So q mod 16 is 5. Next, we have q is going to be redefined as q div 16, which is the quotient corresponding to this long division. This means 693 is going to go down to 43. And last, I increments by 1. Now, since q is non-zero, that means the condition of the while loop is met. So now we have to define r of 1, which is the next element on the list of remainders, to be q mod 16, which is 43 mod 16. So now we have to do long division for the number 43. 16 goes into 43 twice with a remainder of 11. So q mod 16 is 11. And then the next line says q is redefined as q div 16, which is the quotient here. And that number is 2. And then I increments by 1. Q is still non-zero, so the condition for the while loop is still met. The next element on my list of remainders is q mod 16, which is 2 mod 16, which we get a quotient of 0 and a remainder of 2. So q mod 16 would be 2, and then q would be redefined as 2 div 16, which is 0. That's the quotient there. And then I increments by 1. And now this condition is no longer satisfied because I equals 0 is false since I equals 3, and q does not equal 0 is false because q equals 0, which means we end the while loop. And now the output is going to be this list here. What's important, though, is that my number written in base 2 is this, but for base 16, we just change this number to 16 here. So we have to read off these remainders in reverse order. The other thing I want to mention is that 11 is actually B in hexadecimal. So this means that my number in hexadecimal would be 2B5, and that's in base 16. Thanks, everyone, and I'll see you in the next video.